Measuring the impact of early 2025 AI on experienced open source developer productivity. We conducted a randomized controlled trial, an RCT. I love. Apparently, they're going to say the word RTC or RCT so much that they need to pre-qualify it with an acronym or an initialism to understand how early 2025 AI tools affect the productivity of experienced open source developers working on their own repository. Surprisingly, we find that when developers use AI tools, they take 19% longer than without. AI makes them slower. We view this result as a snapshot of early 2025 capabilities in one relevant settings. As these systems continue to rapidly evolve, we plan to on continuing to use this methodology to help estimate AI acceleration from AI R&D automation. So I am very curious about this whole situation. The hard part of what they're saying is that unless if their sample size was very, very large, it's really hard to have some sort of A/B test, meaning that you can't really have an A/B test because you can't like say fix the same bug with AI and without AI. That's not really an available option. And so there's no control, right? Like the control is a bit unusual. Let's see how long these papers are. Okay, the paper is super duper long, so we'll have to kind of come in here and do a little bit of referencing in here because I'm actually very curious about this. Against experts' forecast and developer self-reports, early 2025 AI slows down experienced open source developers. In this RCT, randomized controlled trial, 16 developers with moderate AI experience complete 246 tasks in a large complex projects on which they have an average of 5 years experience. Prior experience or 5 years of prior experience. Okay, so 16 developers, unfortunately, is also a really low number. Now, one could argue that the hard part is like, what am I even looking at? Speed? I'm not sure what speed is. What is baseline? How do they have baseline? How do they have all this? So let's try to see if we can look inside of here to understand what does zero mean? Because zero has to have a meaning such that this has a meaning and then this has a meaning, right? It's a little bit difficult to understand this. Okay, so let's go like this. Let's see. Against, where's my search? Wait, why is it not grabbing that? Against expert. Oh, expert. My bad. Software development is an important part of the modern economy and a key domain. Dude, I'm tired of reading high school papers. To reduce the inferential gap between measurements of AI capabilities and real-world impact, one can measure the impact of AI systems in real-world settings. Field experiments. Existing fields experiments aim at measuring AI's impact on software development, measure outcomes like number of added lines of code or number of tasks completed. Okay, so now we're starting to understand at least what does this mean right here, right? However, AI systems can affect these outcomes without productivity actually increasing. For example, code can be more verbose but functionally equivalent. A task can be broken up into multiple smaller tasks without the total amount of work changing, making it a challenge to interpret these results. This is actually a really great call out. I do like this call out. What they're saying is that you can imagine that if you're just measuring, say, lines of code, what does that incentivize? Well, that incentivizes more lines of code. More lines of code does not necessarily mean more features or more. It does not have any indication whether it's good or bad. It just simply means more lines of code. Also, if you take a task that, say, somebody would reasonably create, and then they take that task and break it into several subtasks, it doesn't mean that, oh, well, this person completed 5 tasks for this person completed 1. The idea, right? Now we're getting into T-shirt sizes. Was that a medium? Was that a small? What was it, right? It becomes very kind of funny. All right, experts and study participants, experienced open source contributors, substantially overestimate how much AI assistance will speed up developers. Tasks take 19% more time when study participants can use AI tools like Cursor Pro. See Appendix D for details on speed up percentages and confidence interval methodology. Okay, I actually let's just jump down to that because that's what we're looking at. For each issue I, we observe the realized completion time T sub I is greater than 0, a binary treatment flag AI sub I is within the set of 0 to 1. The developer's ex-ante forecast of how long the task takes without AI denote by T sub I no AI is greater than 0. If we estimate a log linear model, so the log of T of task I, alpha plus beta multiplied by AI sub I plus, okay. So I can't really envision what the hell that means. Okay, via ordinary test squares and report homoscedastic standard errors. Random assignment of AI guarantees consistency of B for, let's see, our beta hat for beta, What are they trying to say here? Okay, well, I'm actually like, I'm literally too stupid to understand this, but can I throw this in? Can I throw this in a nice, can I throw this in AI? What are they trying to say? The problem is I can't quite understand what they're attempting to say because I don't understand how that equation is derived. I can't visualize what it actually means. All right, Super Grok, tell me, what does that mean? They're looking at how using AI versus not using AI affects the time taken to completion task. Okay, how long the task takes, whether or not AI was used, they're all in the zero. BT, no AI, the developer forecast of how long the task would take them if they didn't use AI, an estimate made before knowing, okay. The regression model, this one right here, they predicted the, let's see, the log of actual completion time, a constant term, intercept, okay, measures the effect of using AI, adjusts for the expected task difficulty via the log forecast time without AI, some random noise. Okay, why include this one? Because harder tasks take longer, and this forecast is a proxy for difficulty. Including it makes the model more accurate and powerful, doesn't bias the estimate of beta because the forecast was collected before AI was assigned. So it wasn't influenced by AI, whether AI was used. What beta tell you? Thanks to random, let's see, assessment of AI usage, B is an unbiased estimate of the causal effect of using AI on log completion time. How much faster or slower things go when using AI, controlling for task difficulty. They're using a regression to figure out if the AI makes developers faster, controlling for how hard the task seemed at the start. Because AI was randomly assigned, they can say that the effect of B is causal. I think I understand what they're saying is that by including the estimation, they can effectively try to make sure that the task takes into account how hard someone effectively, says it is. Okay, so that's what they're saying is that with this is where people were. And so this is economics expert forecast, ML expert forecast, developer forecast during study, developer estimates after study, observed result. Nice. One obvious thing I have is why don't they have like Y Combinator's estimation, which would have something at 10 to 100x faster? Where's that option? I want that one. Okay, motivation. While coding and agentic benchmarks have proven useful for understanding AI capabilities, they are typically sacrifice realism for scale and efficiency. The tasks are self-contained, don't require prior context to understand, and use algorithmic evaluation that doesn't capture many important capabilities. These properties may lead to benchmarks to overestimate AI capabilities. This is really, really great. Like for those that ever followed the AGI ARC stuff, AGI ARC, right? This was like a whole thing that was going on, the ARC Prize being like, oh, we're doing this huge thing about how amazing AI is going to be. And so this is like how we identify who's the best. And this was the AGI tests, which were just like simple kind of little bit of like these type of logic puzzles going on here that when you look at them, they're actually pretty simple. Okay, here we go. We're going to try one. Let's see. We're going to try this task. Here we go. All right, example input. Example output. Oh man, this is looking hard. All right, how am I supposed to see this? Okay, I think I see this. Okay, I understand this. Okay, so what you have to do is you have to look for the things that fit together. So red to red, red to red, right? Side to side, side to side, wider top to top, wider top to top. Okay, got this. Boom, we're done. So we'd have to redetermine the output of this thing here. What is this? So there you go. There's this one. And then input is this. I'm not sure how you do the output being a 3x3 confuses me, right? I'm not exactly sure how I do an output of 3x3 here. I feel like I need to be able to, it's resized below. Oh, you can resize below. Oh, okay. Oh, you resize by doing all this. Oh, okay. I don't want to draw all this out, but I would do something that like this one fits right here. Where's the next one? This guy goes onto this green one. This green one goes onto this yellow one, right? You can kind of see how this would go, right? So it'd go blue, green, yellow, this, and then you'd have to figure out where the heck the rest of these things go, right? This little blue one goes right here. All right, there you go. What is this sorcery? Try by clicking. Clicking just means I'd have to go like this. Okay, I need 3. I need to create the blue object, right? And I'd have to go through and like draw out the blue. It's just a jigsaw puzzle. Yeah, this is just a jigsaw puzzle. All right. Yeah, I can change the size. I understand that I could go in here and go, okay, I want this thing to be, I don't know, a 20 by 20. Okay, cool. Now, but I still have to go in here and like draw the whole thing and be like, okay, the green one is like 1, 2, shoot. The green one is 1, 2, 3, 1, 2, 3, 1. This is what humans are really bad at, right? Okay, hey, caught. I'm bad at this. Prime failed the AGI test. I'm slow. Slow AF. All right, slow AF. Oh, can I copy? Oh, that's nice. Select. You can select. Oh, nice. Oh, you can select. Oh, that's cool. Copy. Paste. Oh, that's nice. Oh, okay, that does make things a little bit nicer. Can I control X? Can I control paste? Nope, can't. You can't control X. Okay, whatever. Whatever. Now make the pieces so they're rotated and reflected. Yeah, there you go. Whatever. I'm not AGI. I'm clearly not AGI. But anyways, that test, it does not capture that. Like, I think this thing rightly calls out. I think they're right on their motivation, which is that those type of tests don't actually reflect real world requirements, right? There's all sorts of other things. There's a context you need to understand. There's all sorts of, right? There's all sorts of other factors that come into it. You're not given perfect examples, perfect output, perfect example, perfect output, perfect example. How would you solve this, right? You're not given that. Instead, it's like you got a PM that comes in. It's like, dude, you need to make that like more user friendly. And then like somebody has to go, what the hell's more user friendly, right? Like you got to like think, what does that even mean, right? Like there's no nothing that you could just simply like do, you know? You have to like take all this information and attempt to do something, right? So I think this is actually I think this is really good that they're trying to measure it in a different way. In the other direction, because benchmarks run without live human interaction, models may fail to complete tasks despite making substantial progress because of small bottlenecks that a human would fix during real usage. Also, a really good call out in the other direction that, you know, we can just fix things along the way and make it way better. This could cause us to underestimate model capabilities. Broadly, it can be difficult to directly translate benchmark scores into the impact of the wild. One reason we're interested in evaluating AI's impact in the wild is to better understand AI's impact on AI R&D itself, which may pose significant risks. For example, extreme rapid AI progress could lead to breakdowns in oversight or safeguards. Measuring the impact of AI on software developer productivity gives complementary evidence to benchmarks that is informative of AI's overall impact on AID, R&D, and acceleration. Is this that the whole like 2027 is going to be the end of the universe type thing? Or I don't know if you've seen that, but there's all these forecasts being like 2027. That's when the AI overlord that's when super intelligence touches down and we're all effed.
Give me the meat and give it to me raw.
All right, to directly measure the real-world impact of AI tools on software development, we recruited 16 experienced developers from large open-source repositories, averaging 22-plus stars and 1 million lines of code. Okay, so this is good. So these are very large tasks here. Okay. And that they've contributed to for multiple years. Developer provides a list of real issues, 246, that would be valuable to the repository, bug fixes, features, and refactors that would normally be part of their regular work. Then we randomly assign each issue to either allow or disallow the use of AI while working on the issue. When AI is allowed, I wonder what they mean by AI. Do they simply mean, because they say Cursor Pro? Oh, man, so there's a whole bunch of questions I have with this test already. Like there's a whole bunch of stuff that I think needs to be taken into account. We'll get there. Hold on. Let me just read what they have to say. Developers can use any tools they choose, primarily Cursor Pro with Claude 3, 5, 3, 7 Sonnet Frontier models at the time of the study. When disallowed, they worked without generative AI assistance. Developers completed these tasks, which averaged 2 hours each, while recording their screens, then self-report the total implementation time they needed. We paid developers $150 an hour as participation. Oh, so this is how... Dude, that's a great way to get developers. Hey, you know what's a great way to get developers? $150 an hour. What a great idea. Let's go. Hey, dude, you got some open source I can work on? Hey, bro, can I work on some open source? I could use that. Oops, took me 2,000% longer. Whoopsies, I accidentally worked 4,000 hours. I will literally suck dick for $150 an hour. Damn, that's crazy. That's crazy that you went straight to the dick sucking. You didn't even like start off with writing Java. Better than writing Java, that's for sure. I'd rather suck dick than write Java. Okay, slow down there. Okay, slow down. All right, here we go. Standard libjs. JavaScript has a standard library? Dang, okay. I didn't realize that. jQuery. Oh, jQuery. Oh, yeah. Oh, my bad. Yeah, it's called... Sorry, I got stun locked so hard because I'm like, what's the... But, jQuery, that makes perfect sense. Okay. I do love this, that forecast with AI disallowed, forecast with AI allowed. They assume they're like an automatic assumption that you will just go faster by a huge percentage. Like that's a good percentage faster. These are really good percentage fasters. All right. When developers are allowed to use AI tools, they took 19% longer to complete issues, a significant slowdown that goes against developer beliefs and expert forecasts. This gap between perception and reality is striking. Developers expected AI to speed them up by 24%, and even after experiencing the slowdown, they still believed AI had sped them up 20%. Let's pretend this is true for a second. Jobs are so back, people. I don't know if you know this, but man, the big beautiful bill had that R&D tax credit that was make it so that software developers are considered R&D expenses, which allows you to actually write off the taxes within a year as opposed to over the course of 5 years, which means that companies are going to be more likely to be able to hire people. Now, apparently, based on this study, they're going to actually be 19% slower than they were beforehand. Think about this for a second. Think about how amazing that's going to be. We got the big beautiful study. We got a big beautiful bill that apparently is going to help us software developers, and everyone's going to go slower. We're going to have so much Wing happening. It's not even, no. I understand that this is probably, right now I'm pretty skeptical about this whole thing, but I do love this idea, right? This is obviously only in the context of these developers. We don't know anything about these developers. Again, I will give my opinion, but I'm waiting for meat's back on the table. Dude, meat's back on the menu, boys. But I'm going to give my opinion here soon. I'm just trying to I'm trying to wait. I want to gather all the information first. But let's see, below we show we show the raw average developer forecast times and the observed implementation times. We can clearly see that developers take substantially longer when they are allowed to use AIs. Let's see, average developer forecast versus times. Okay, AI disallowed, higher. AI forecast allowed. AI disallowed times. AI observed allowed times. I know this isn't a large sample. I know this is not a large sample, but this is so funny.
Can you believe some chatter asked me to send you bit for coitus? Crazy times. Kick.
Thanks to Fiasol. Dude, that's so funny that.
Give it to me raw.
I mean, okay, so I got to start giving some of my opinions here. I will say this. I do think that people who have AI feel more ambitious and potentially would take on larger tasks, assuming they can accomplish it easier due to the power of the AI. So maybe they're completing tasks that are harder because the harder is the implementation time, right? Now their forecast is completely wrong, right? This is very funny to see. Like what this says to me is that not using AI, they actually are pretty good at forecasting. This is actually a really crazy forecast going on right here, right? That's actually really amazing. Forecast versus actual time, assuming these are the exact same amount of time periods, like that's really cool. This is obviously super out of whack, but again, maybe they're also just simply doing tasks in which are larger than they'd normally do. It's kind of hard to measure, like what is, I wish I had a little bit more understanding because I kind of wish they would have had, what's it called? I kind of wish they would have had the AI allowed forecast also be mapped on top of like what they would have accomplished this without the AI assisted task and then see are those two really close? Because maybe on AI assisted tasks or sorry, let me say this again. I'm totally using all the wrong words. I would love to be able to see their AI allowed forecasting to be mapped on top of what they forecasted if they couldn't use AI, because perhaps if they couldn't use AI would align much more closely to what the actual outcome is, meaning that the difference AI is making is not as big as we are perceiving, at least for these 16 developers. It's just that this difference is so striking, right? This difference is literally going to be what, practically 30% more. Now try a 200-hour task. Yeah, I mean, again, there's also so much, so much stuff. Disallowed versus allowed. Oh, I see it. Okay, people are saying why the test. Okay, so they actually are doing that. Okay, so this is what's happening right here. Okay, well, actually, no, this is kind of confusing. I wish they wouldn't have done this. They should have broken this graph up a little bit more. I would love to be able to get my hands on this data. Because, okay, so what's happening here is ends 246. So there's 246 tasks. So of those 246 tasks, 110 of them were done without AI, and 136 were done with AI. That's 246, right? So this is the total estimation time of all of the tasks without AI. This is the total estimation time with all of the tasks with AI. This, of the tasks that were all done without AI, this is their total time. This, of all the tasks done with AI, is their total time. I would have loved to see, of the 136 tasks that were the ones that said they had AI, what was their non-AI forecast? Yeah, it's not average. Yeah, sorry. When I said average, I meant like, or sorry, when I said total, I meant this is like their average. You know what I was trying to say? It's not their total. It's not their sum, right? My bad. My fault. Incorrect language. Called me out. But you know what I was trying to say. You know what I was trying to say. Don't be pedantic, but also good on you for being pedantic. Okay, but I'd love to see of these 136, what was their estimated time with AI disallowed. Now, the hard part is you can't do these tasks now without AI. Like, that's what I would love to see is I wish you could have got a second developer of equal familiarity with the repo, being able to work on the same tasks, and then being able to measure the difference between the two, right? Like, that would have been at least a lot more interesting of an observation. You know, one could argue, hey, well, you also have like experience and all this kind of stuff, right? And also, one thing that's not kind of in this little graph right here is what is the quality of these 136 tasks? How many of them had code that was modified within a week? How many of them led to a bug within the next 2 weeks? Like, were more people using the old-fashioned grandpa coding with their hand, causing more lines of code to be changed later on? Or were the people doing the AI caused more change? Like, there's some downstream or second-order effects that aren't measured with this graph at least. Let's see if maybe they address it later on. Because that's also just interesting. Because if you make a change and then that code is modified within a little bit of time, something about that says that your change wasn't sufficient, or your change was sufficient, new requirements came in. So it's hard to tell. All right, the paper might mention success later. Nice. Given both the importance of understanding AI capability and risk, the diversity of the perspectives of these topics, we feel it's important to forestall potential misunderstandings or overgeneralizations of our results. We list claims that we do not prove evidence for in Table 2. Okay, we do not provide evidence that AI systems do not currently speed up many or most software developers. True. This is about these specific ones. We do not claim that our developers or repositories represent a majority or plurality of software development work. All of this I can completely agree with. I'm glad that they make this claim because this is a very good and astute claim. AI systems do not speed up individuals or groups in domains other than software development. We only studied software development. Also good. AI systems in the near future will not speed up developers in our exact setting. Progress is difficult to predict, and there has been substantial AI progress over the past 5 years. Also, the correct answer. I don't know how to predict where software is going. To be honest, reading this article, 100% of these guys were fixing after AI anyways. I'm not sure. I have no idea. There are not ways of using existing AI systems more effectively to achieve positive speed up in our exact settings. Cursor does not sample many tokens from LLMs. It may not use optimal prompting, scaffolding, and domain repository-specific training, fine-tuning, few-shot learnings could yield a positive speed up. Yeah. So I like this. Again, I love this breakdown saying, hey, we're not trying to make these really bold we're not trying to make these bold claims. Instead, we're saying that, hey, this is just what it looks like from here. There's maybe many different ways to be able to make things, better. We investigate 20 potential factors that might explain the slowdown, finding evidence that 5 likely contributed to. Over-optimistic about AI usefulness. Developers forecast AI will decrease implementation time by 24%. Developers post hoc estimate AI decrease implementation by 20%. High developer familiarity with repositories. Developers slow down more on issues they are more familiar with. Developers report that their experience makes it difficult for AI to help them. Developers average 5 years of experience and 1,500 commits on the repository. Large and complex repositories. Developers report AI performs worse in large and complex environments. Okay. Repository average 10 years old with 1.1 million lines of code. Lower AI reliability. Developers accept less than 44% of AI generations. Majority report making major changes to clean up AI code. 9% of the time spent reviewing, cleaning up AI outputs. Implicit repository context. Developers report AI doesn't utilize implicit tacit knowledge or context. Okay. I'm going to make a different observation here. My different observation that could be a factor. One could potentially say that some of these developers, maybe they're a bit obstinate on using AI. And so perhaps that affects their ability to work as fast because they feel like they have to generate. They get upset, then they just rewrite. And so then there's like this whole kind of problem going on there. So there could potentially be some level of just like general angst against the AI generation that makes it so that they slow down. That perhaps isn't captured in this. I think people are bad at perceiving. That's one thing that it really says right here to me. That's a skill issue. To be honest, everything's a skill issue, right? I mean, I love saying skill issue as a joke, but reality is everything's a skill issue. Name one thing that's not a skill issue. If anyone does something, if anything is done and we say, hey, this wasn't done as good, it's a skill issue. It's just kind of, it's a cop out for having a real thought through it, right? Winning the lottery. It's winning a lottery is a skill issue. You planned on winning the lottery you played the lottery intentionally. That's a skill issue. Playing the lottery is a skill issue. I hate to bring that to you. You just happen to get a reward of a skill issue. That's the mistake. Anyways, all right, your inability to understand that not everything is a skill issue is a skill issue. Boom. Everything's a skill issue. Developers accept less than 44% of AI generation. That means they spent a lot of time generating than regenerating. Like, generation of changes aren't, they're not instantaneous, right? Majority report making major changes to clean up AI code. Again, I have this theory that, we spend a lot of time waiting for generation, which means that you will often lead to you doing other tasks or getting distracted, which adds more time, right? You don't have a tight loop. You have this kind of wider loop that maybe you get up to go you get up to go do something. You go do something else. You start reading something else. So you add a bunch of inefficiencies because you're not directly engaged in the activity, thus making it so that you are taking longer, but maybe you're not actually taking longer. There's also not the idea of concurrency of tasks. Like, how do I know that there's not a concurrency of tasks going on here? Which I think would be really interesting to measure, which is, okay, yes, you're using an AI, but now you could potentially be working on 3 bugs at the same time. So does that result in you actually having an overall speed up despite each one of the bugs taking longer than you would have been able to do by yourself hand coding it, right? There's a lot of questions that one could say. Also, at the end of the day, is the answer simply speed, or is there something about slowing down to speed up that actually makes more, that makes more sense? There's a lot of these questions that I feel like these things never ask or answer. We rule out many experimental artifacts. Developers used frontier models, complied with their treatment assignment, didn't differentially drop issues, dropping hard AI disallowed issues reduced the average AI disallowed difficulty, and submitted a similar quality PRs with and without AI. The slowdown persisted across the different outcome measures, estimator methodologies, and many other subset/analysis of our data. See the paper for further details. Does this one go somewhere else? I do want to start looking through this paper. Maybe there's something cool in it. So how do we reconcile our results with an impressive AI benchmark scores? Well, again, I think I've been saying this from the beginning, and I think a lot of people say this on the internet. Why is every single model scoring 99% on all these benchmarks? Why is every model the greatest benchmark scorer of all time? Yet, every single one of these models having amazing benchmark scores, how come everybody says Claude 3.5 is horseshit now? Did it not score amazing on benchmarks? Were the benchmarks not incredible? Are you saying that these companies have a perverse incentive to train on the benchmarks or to attempt to look good on the benchmarks without actually being good? I refuse to believe that. Sam Altman is a gem to society and would never, ever do anything to be perceived as say, optimizing for commercial success. And anecdotal reports